This lesson is on triangle similarity. In this lesson, we will learn about the 3 different postulates that we can use to prove that triangles are similar. You will notice that the triangle similarity postulates look very familiar because they are, in a way, like the postulates we use to prove that triangles were congruent. So let's take a look. The first postulate we're going to look at is the angle-angle similarity postulate. And what that postulate says is that if 2 corresponding angles are congruent, then the triangles are similar. So let's look at 2 examples. Example 1, determine if the examples below are similar by angle-angle similarity. If yes, write a similarity statement. So this is much like what we did with congruent triangles, except instead of writing congruent, we're going to write similar. So if we notice in this example, we have 2 angles that are 75, one in each triangle, and then we have 1 angle in each triangle that's 31 degrees. So if we have those 2 angles the same, we know the third angle's the same. There's something called the third angles theorem that tells you that if 2 angles of one triangle are congruent to 2 angles of another, then their third angles are both congruent. But that only makes sense, right? So if we do have 2 angles congruent in each triangle, therefore we know the figures are similar. So we'll say yes. And for our similarity statement, we will say triangle ABC is similar to triangle DEF. Okay. In the next example, we see that we have 2 angles already marked as congruent. We have this angle, angle V, and angle Y. But there's another angle that we know that happens to be congruent on both of these triangles, and that would be these 2 angles. And why are those 2 angles congruent? Because they are vertical angles, and we learned about that, and we've talked about that pretty much all year long. All right, so we now have identified 2 congruent angles in each triangle, and so we can say yes, the triangles are similar, and our similarity statement would be triangle VWX is similar to triangle YZX. Another way that we can prove similarity is using the side-side-side similarity postulate. And that postulate says if all corresponding sides are proportional, then the triangles are similar. Let's look at some examples. It says determine if the examples below are similar by side-side-side similarity. If yes, write a similarity statement. So the first thing we want to do is compare each of the 3 sides on the triangle to determine if they are proportional. The main thing you want to do is just list them in order because if as far as the length, because if they are similar, then the corresponding sides will be you'll be able to list those also from least to greatest. So if I'm looking at example 3, we have one side that measures 3 units and the corresponding side measures 6 units. Those are both the smallest sides on both of the triangles. And this one, 3/6 equals 1/2. We're going to simplify it. Okay? Then we'll look at the second longest side, and we have PR, which is 4, and SU, which is 8. 4/8, we write that ratio, we get 1/2. Okay, so far we're good. Now we're going to look at a third side, and that is 5 here and 10 here. All right, so we write that ratio, 5 over 10, and that equals 1/2. All right, so since all three ratios of the three sides are the same, then we can say, yes, they are similar. And because they're similar, our similarity statement would be triangle QPR is similar to triangle TSU. Okay, so make sure that you look at the sides and the side lengths and see which ones correspond, because they're not always oriented in the same direction. So it's important that you pay attention to which ones correspond rather than just where they show up on the paper. In the next example, example 4, we're going to do the same thing where we write our ratios and then compare them. If all three ratios are the same, that means all three sides are proportional, and we can conclude that the triangles are similar. So let's see, we're going to first look at CD, which is 30. Oops. And then 30 is corresponds to side FG, which is 24. All right, so we simplify that fraction to 5 over 4. All right, that's the first side. Now we're going to compare the middle length side. So this one, 32, would have to be compared to 25. 32 over 25, if we were to simplify that, we are going to get, oh, that can't be simplified. All right, so since that can't be simplified, we know that these triangles are not similar. Okay, if they are similar, we can write a statement that looks like this. We would have been able to say 30 over 24 is equal to 35 over 28 is equal to 32 over 25. Okay, so looking at all three sides, that is not a true statement. So I can say, nope, these three triangles are not similar. All right, moving on to our third example. And the third way that we can prove that triangles are similar is using side angle side similarity. Now, side angle side similarity is very similar to the congruent triangle postulate for side angle side congruence, except instead of saying the sides that are, that form the angle are congruent, we see whether those two sides are proportional. So we state it like this: if two corresponding sides are proportional and the included angles are congruent, then the triangles are similar. So let's take a look. We have in our first example, example 5, we have the side that measures 8 units and the side that corresponds measures 6 units. So our ratio for this side would be 8 over 6, which simplifies to 4/3. And now we'll look at the angle in between the two sides that we have the measures for, and that would be this angle, angle K, and it is congruent to angle N. So we have our included angle that is congruent. So far we are proving that they're congruent. Let's keep going. The next side is 20 units and the corresponding side is 15 units. So we'll compare that ratio, 20 over 15 is also equal to 4/3. And so because these two ratios are both the same, then I can write the statement that yes, they are similar, and its triangle JKN is similar to triangle MNP. Now, in example 6, we have a triangle within a triangle, and we're going to try to prove that these two triangles are similar. And so the first thing we're going to look at will be the two sides, because remember, we need proportional side, then we need the angle in between to be congruent, and then we need another proportional side. So we'll compare side AD, which is here, 15, with side AB, which is 25. Okay, so 15 over 25. Let's write that ratio. And we'll go ahead and simplify it to 3/5. So that's what we would consider our first side. And now we're going to look at the angle. So remember, we're looking at side, angle, side similarity. So now I'm going to look at the angle in between. And in this case, this angle, angle A, is the angle that we're looking at, because based on the reflexive property, we want to see if angle A is congruent to angle A, which obviously it is. Angle A is congruent to itself. That means we have a congruent angle that's included. Okay, so we've met side and angle. Now we're looking to see if the other side is proportional. So let's write that ratio. First thing we want to look at is AE, and we will compare that to AC. So we'll write that ratio, which would be 12 over 21. When we simplify 12 over 21, we get 4 over 7. Okay, so comparing our two ratios, 4 over 7, so 15 over 25 does not equal 4 over 7. So therefore, we do not have two sets of proportional sides. So we have to conclude that no, the triangles are not similar. So in this lesson, you've learned about the three ways that you can determine similarity: angle, angle, side, 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 and side, angle, side. So now you will apply those postulates in order to determine if triangles are similar when you do some practice. That is all for this lesson. Thanks for watching.